I don't know, obviously, what those specifications are going to be. I'm probably going to predict, however, that they're going to have like the high 2000 number of shaders. So you're probably looking at a number of, you know, the mid 40s-ish at a rough guess. I'm saying ish because they might change it, obviously, for the next generation. They might decide to go a little bit lower. And that does lead me to wonder how that's going to fit in with Polaris, what they're going to do with the Polaris architecture. Are they going to retire it? Are they simply just going to go to the 500 series and say, you know, thanks for the service, 400 series, you've been an absolute blast. And to be fair, no one can deny that Polaris has done AMD a really good service. It's helped keep them financially stable, or at least has put them more financially stable. It's helped win them over in terms of gamers. And as I mentioned in my Crimson Relive review, the drivers, the revisions they've made of those drivers is pretty substantial. One can make a very compelling argument that if the Crimson Relive drivers, especially the latter ones, the ones that have just been released, I can't remember their version number is offhand, but if they had been out when the GTX 1060 had launched, Nvidia probably would have been a lot less confident, because basically the RX 480 performance, if you could do some Googling on this, but the RX 480 performance has gone up by about 10%. Now what I want to know, and this is very off topic, what I want to know from Nvidia is what are they going to do to counter AMD? And I want them to counter AMD, that's the thing. Because as much as I want AMD to succeed, I also don't want the only choice in each of my videos, or each comment, or each person who messaged me when they're like, what graphics card? Well, you need this AMD card, because it's A, not great for the customer, and B, it doesn't give you choice. Because what really sucks is if you like a lot of features from one graphics card manufacturer, for example, let's just for example say you've got a nice G-Sync monitor, but you know these cards come out and Nvidia have nothing to counter them, then you're basically forced to jump to AMD, and that sucks if you've got a FreeSync monitor, sorry, G-Sync monitor, and the reverse if you've invested into a FreeSync monitor. So that's why I like both companies to be competitive, because I think it's great for the industry, and it's also one of the reasons that I do want, as much as I want AMD to rabbit punch Intel, so that Intel get its finger out when it comes to the number of cores for the mainstream. I don't want AMD to be the only choice for gamers, because it's not healthy, and it breeds complacency in the marketplace, at least in my opinion. But that's just, you know, essentially my thoughts on the subject. Anyway, I probably went a bit too much onto this particular thing. I didn't really mean to drag that on so long, but hopefully you've enjoyed it. I shall see you all soon. Take care of yourselves. Bye for now.
This is Gordon and Brad Truckers. We are bringing you a special full nerd episode from CES. And if you didn't know, AMD is back. We are here at AMD's booth where they've got Vega, they've got Ryzen, and we have a super special guest. Radeon Technologies Group head honcho and the smartest guy in the room, Roger Kadori. So we are going to ask questions that we want to ask about Vega, and then we are also encouraging you to please ask your questions. And I'm going to say it up front because he can't tell you how much. He can't tell you when it's coming out. He can't tell you the clock speeds. And if your username is Jensen, he's not telling you anything. But please ask anyway, because we want you to ask as many questions as you can. Brad knows a lot more about GPUs for me, and he actually has a lot more Vega questions. And I'm hungover, so I'm going to let him ask the first question of Roger.
Hey, how's it going, Roger? So, you announced a bunch of new technical preview for Radeon Vega, right? And one of the big things is the high bandwidth cache and the high bandwidth cache controller. And, you know, it's improved speed, right? Improves speed, improves it, makes very large amounts of memory available to the graphics card, right? So that obviously has a lot of benefits for enterprise space, business space. What sort of benefits can gamers get out of that?
Yep, absolutely. First off, both Gordon and Brian, thanks for being here. And I, as always, whether it's on camera, off camera, I would love nerding out about GPUs with you guys. So on high bandwidth cache, right? So from a gaming perspective, right? We looked at all the modern games, the big games that push memory hard. And one of the things we noticed is that we call it utilization, right? Video RAM, VRAM utilization. We look at how much of the VRAM that the game allocates, right? So if the game, say, needs 4 gigabytes of textures or memory, when we looked at actually how much of that memory is actually used to render pixels, we found that most games don't use more than 50% of what they allocate.
Yeah, you were saying that's even with Witcher and stuff.
Yeah,
like that. Big name stuff.
Yeah, and they are optimized games, and that's because the old GPU architecture doesn't give you flexibility to move memory in a fine granularity. So with Vega and with the high bandwidth cache and high bandwidth cache controller, for games, it'll utilize the amount of frame buffer you have much more efficiently. So effectively, you can think of as Vega will be doubling your memory capacity for games.
So basically, like a game that says it uses 4 gigabytes of RAM right now is in actuality using 2 or so, for example. And you're saying with Vega, it'll actually allocate 2.
Exactly.
Is that something that developers are going to have to plan around? Or is that something that you guys
No,
handle
so
100%?
when developers take advantage of that, of course, they can throw in more high-resolution assets and all, right? One of the discussions, Gordon and me were having at dinner is that, we run games at 4K, right? Because we can just crank up the resolution and all. But today, a lot of assets, like the textures and the geometry, the models and all of that stuff, they're not created for 4K, they're created for 1080p. So you're not getting full benefit of 4K because the developer, it's a lot more expensive for those assets. And they don't do that because they cost lots of memory, it doesn't fit their minimum spec machine and all of those things, right? So Vega will encourage developers to, because they have high resolution assets, ship them, right? Use them, ship them, and so it makes 4K gaming kind of, I think we are entering the 4K gaming era, but it will take a few years to get a real high quality 4K game.
Okay.
So I got to ask though. So if it sort of gives you more effective memory, use of the memory, your frame buffer, does that mean future video cards won't need as much frame buffer? Like right now, marketing, it's very great to market cards like, hey, we've got an 8 gig, 6 gig frame buffer. Yeah. In the future, is it possible people only have 3 gig or 4 gig?
So what the high bandwidth cache and the cache controller does it actually changes the entire conversation around what is your memory, right? And what is your how much high bandwidth cache do you have and how much speed do you have, right? So one of the things you notice is that even in the current video card reviews, there are many 4 gigabyte cards that beat the crap out of 8 gigabyte cards, okay? So, but unfortunately, we haven't, set up the industry right about what is important. Right? Nobody actually understands how much bandwidth their card has, right? So, bandwidth is many times much more important than how much footprint do you have, right? So, I think one of the things, what you'll see us doing, and again, the Vega architecture preview was just a very high-level one, but in the coming months, we'll be changing the entire conversation around how to look at memory, how much memory you got, how much cache you got, how much bandwidth you got. And in fact, we want to educate to the gamers the importance of bandwidth. In fact, we want to put front and center on the box, okay, how much bandwidth you have, which we don't right now. Even the most
quantity, it's your capacity.
Yeah, only the the nerdiest of the nerds know. They can tell, oh, I have 384 gigabytes per second, right? But we want to make that much more very clearly visible because that's really important for performance. Then exact amount of footprint that you have, and with Vega, because we are expanding the footprint because the addressable memory is literally terabytes. By the way, the other thing that it opens up for games is a completely different forms of rendering that they could do when you have that sparse access of terabytes of memory, right? There are very many interesting rendering approaches that people were looking at even 10 years ago, 15 years ago, Carmack and all, that they didn't with the way GPU managed memory. Now all of those stuff will come back and say, maybe I can do this entire thing way differently if I have ability to do sparse accesses to textures much more efficiently, right?
So I guess in the future we'll see, hey, you'll see high bandwidth cache and label on the box. It's really hard to re-educate consumers to
exactly.
go like,
yeah.
you know, I want this card with 12 gig of frame buffer. I'm not going to take one with 6.
Yeah, yeah.
So
it's hard, and we are.
That's why he's here, to tell you one.
It's very, very hard. You know, changing nomenclature. You know, actually, you know, memory. In fact, not just graphics, right? Changing memory hierarchy, changing memory types for computer industry has always been a difficult problem. Remember the transition when we went from hard disk to SSD? How hard it was initially, because, you know, SSDs had smaller sizes and they were expensive and all. That was hard, right? You know, it took so many years to kind of, you know, now.
Some people still haven't bought into it.
Right, in there, right? And they do hybrids and other stuff in there, right? And I mean, that's an extreme example of memory hierarchy. This, one of the reasons why we took the approach with the high bandwidth cache controller is that all the lessons learned from the previous memory transitions. So you can make all of this stuff work only if you make it transparent to the user, where user doesn't have to make this tough choice of, hey, do I buy a 128 gig SSD that boots fast and all, or you know, 2 terabyte hard disk that is cheaper, right? So I want to take that, you know, Sophie's choice out of the user stuff. It's like, don't worry. You just don't have to worry, right? You know, just, you know, if you have, you know, look at how much bandwidth you're buying and how much cache you have in there, right? And everything else takes care of itself, right? Don't worry, right? That's kind of where we need to get to. Of course, we need the whole ecosystem to come together before it happens. So we don't have any rose-colored glasses that it's like kind of, you know, on day one we are able to educate people and all. They will want to know kind of, you know, the old terminology will take a little bit, you know, to move out. But Vega is the beginning of the architecture, and we have to bring that concept down to up and down the stack as well, right, to change the terminology. So, you know, and we have a multi-year plan to do this.
But on day one, will games that already exist will they consume less memory, as you're saying, because they're acting more efficiently? Because Vega's doing it?
So basically for them, they don't see it, you know, they're just allocating the memory to the APIs like they are. They get all the allocations, you know, they won't see a difference. For example, right, if you, today's game, say, you know, because they say it's built for 4 gigabyte, and say you have a 4 gigabyte card, it all plays well, but, you know, when you swap in, for example, you know, when you alt tab out of a game and, you know, go into a browser or something to do something quick, and when you come back, it takes a long time, right, because the whole thing was swapped out and swapped in. So with Vega, you'll see those stuff be much more efficient because it didn't really, like I said, it wasn't using all 4 gigabytes. It was only using a portion of it. So we didn't actually load that up all inside your, you know, precious cache. So, you know, you can pull in the Windows stuff and all more efficiently and all. So you'll see those kind of benefits. But let's say you have a game that wants to push 8 gigabytes, right? When you turn high detail on and all of that stuff, it will run much more efficiently in a 4 gigabyte configuration. Right?
Okay.
Right. So you'll start seeing those kind of benefits.
Okay. So I got a question. We talked a little bit about this yesterday, and you just mentioned it earlier that most games, you know, as an enthusiast, I like to run everything max resolution, you know, ultra, everything, ultra. You're saying it just doesn't. You're saying the difference between ultra and the normal setting just isn't that big of a deal.
Yeah, you know, this is kind of the interesting thing. I kind of, you know, myself kind of personally realized just recently, right, that some of the games, those ultra settings, right, so the game is developed for a default setting, right? The whole experience is developed around a default setting, and that's where your artwork is created to look good in that settings in there, right? And it's very expensive to create artwork, by the way. The most expensive thing is to create artwork. And the higher resolution the artwork is, the more expensive to create, okay? So these slider bars to the right, the games are not, you know, the artwork wasn't created to that stuff. What they do is just, you know, scale up existing textures and all of that stuff. So they don't look that much better, really, but it makes us feel good as if, you know, we're running side detail and all, right?
I feel great when I run everything in Ultra at 70 frames a second.
Right. So I think there is something to be said in terms of like, in terms of actual game experience, right? I mean, we all are kind of, geeks and nerds. We like benchmarking in various ways. I understand that, but for a broader gaming audience in there, take a look at, games have really spent time, creating the ultra mode for you. The developer invested, it's worth for you to run. If not, you're just wasting cycles,
throwing away performance.
You're throwing away performance.
Throwing away money.
Yeah, you're throwing away money.
For
exactly. And don't do that.
Yeah.
Really, it's very, very expensive. These games have cost $200 million to develop. So it's like doing a true 4K game is going to be very expensive.
Is there anything? Because I'm, as an enthusiast, I do want those ultra textures. What will it take to get developers to for most of them to do that? Because I know most of them don't,
Yeah.
but I know a few do.
A few do, and I think what you'll see, because so with high resolution displays and high DPI displays, things like one of the things that's very, very obvious that attracts all of us is that the heads-up display that you have in the game, right? The text and other stuff looks very sharp on a 4K display, right?
Yep.
Because anything that has high frequency edges like text looks immediately beautiful. But the natural things that are in a game, your trees, your this stuff and other things, you actually have to look hard to say, like, is it really better or not? And if you do, you have to almost do a side-by-side to kind of see the things in there. So what I think will happen is that the obvious kind of high frequency stuff, developers will start putting assets for those, and we are seeing that already, right in there. That they're redesigning the UIs and all to give the benefits. But for the entire world to kind of become high resolution, I think again, like I said, when 4K panels become more pervasive, they'll feel like that the investment is worth. And I think the good news is, like, this year we're starting to see the prices of the 4K panels
Start to
get there, right? So I'd say, like, by Christmas 2017 will be interesting, but I think that's why I said we are really entering the 4K gaming era now. And if you look at how long, we kept saying 1080p is here and all, but like to have smooth 1080p play gaming across the board, it took a while.
Yeah.
And I think that's what we'll see with the stuff. And our goal, obviously, it's my personal goal in 2017, is to kind of bring that 4K fluidity to the market, at least at some segments in there, but kind of really drive that to be, pervasive. Then the developers will start kind of taking it much more seriously.
And that actually, well, go ahead. I don't want to.
I was going to crack a lame joke. You can go ahead.
Go ahead. I missed
So
the
people
joke.
always make the joke that their New Year's resolution is 4K. It sounds like yours literally is.
Yeah. So this brings up another thing. You saying you've been toying with getting a PC that somebody can build for $1,000 that will play 4K games this year. Right?
That's my that's kind of my kind of New Year stretch resolution, right? And it's the whole PC in there, right? And funny enough, and I actually was looking at the articles you guys did right before Christmas on the PC gaming PC builds that you did, right? The budget PC and the performance.